So now that we've introduced the concept of velocity, which is the change in position over time, we can wonder about what happens when velocity changes. So that leads us to define our last vocabulary word, which is acceleration. So acceleration is the change in velocity over time. And just like we did for the variables before this, we would write the average acceleration is equal to the change in velocity over the change in time. And just like we did on the previous slide, we would write this as v final minus v initial divided by t final minus t initial. And just like we did on the last slide, we're going to draw a velocity versus time graph this time. So here is a vertical axis. Now instead of position, we have velocity. And over here, we have time. And I can do exactly what I did on the previous slide, where I started some initial speed, and I go to some final speed. And I started some initial time, and I go to some final time. And if I look at the coordinates here, I'm going to start at a point here. Now this is velocity time space, not position versus time space. OK, so we're doing something different here. This is not a graph of position. This vertical axis is actually how fast I'm going. But the way that these quantities are defined, I can still draw a line segment that connects these 2 points, these 2 speeds as a function of time. And it will still be true from my definition that the slope of this line is going to be the average acceleration. So the average acceleration is really v final minus v initial over t final minus t initial. And so even though we're not talking about position anymore, this is a graph of speed versus time. The slope of that graph gives me acceleration. So this is a fundamentally different plot, even though it looks identical to what I just drew for position versus time, because now the vertical axis is speed. But the acceleration and the velocity are still related in the same way. And so again, just like we were talking about what happens when I look at smaller and smaller intervals of time and try to define the slope of the line, I can define the instantaneous acceleration, a, and that is going to be equal to the limit as the time interval gets really small of the change in velocity over time. And just like we did for velocity, we can write a is equal to the derivative of the velocity with respect to time. So this allows me to define the instantaneous value of acceleration at a point. Again, this is a calculus concept that we're not going to emphasize in this class, but if you're interested in learning more about it, I encourage you to look at the calculus primer.